Hi everybody, we're going to be looking at equation solving today, and equation solving is our next journey in our algebra unit. I want you to realize the big picture here. A lot of the problems you're going to look at and go, well, I can do that in my head. But we are starting the foundation of algebra concepts and algebra steps that you are going to need to use when things get harder. So the better the foundation you have now, the easier things will be later on. So go with the steps that are going to be shown to you today. You actually have been doing algebra since you were in elementary school. We might have a problem 4 plus triangle equals 10. How would you solve for the value of the triangle? I know many of you would go, well, I know it, it's 6. That's kind of silly. But what I want you to say, what are you saying in your head or your elementary brain to get to that value of 6 that you probably just kind of popped in your head? And 15 equals 8 plus triangle. What is the value of the triangle? Well, most of you could look at that and go, oh, the value of the triangle is 7. Why are we doing this? But what operation did you really do in your brain to get that? What you did is the inverse operation, or many of you did the inverse operation. Inverse is another word for opposite or reverse. Okay? What you were looking at was 4 plus triangle equals 10, and triangle was 10 minus 4. Okay, you were looking at 10 minus 4. It might have become more automatic because I chose something easier. 15 equals 8 plus triangle. 15 minus 8 gave you your triangle. So that's called the inverse operation. If we looked at this, I want you to pause for a second. Don't give the answer. I just want you to think, what is the inverse operation? 9 equals 6 plus box. Okay, well, I'm looking at addition, and to really get that answer, I would have done subtraction. That would have been my inverse operation. 22 equals box minus 10. Oh, I've got a subtraction problem there. So what did I subtract from 10 to get to 22? I would have done an addition problem there for my inverse. So now we're taking these boxes and triangles and question marks, and now we're showing it in algebra form, which is using a variable. I can use any letter in the alphabet. I'm just using X here. So I'm swapping out the pictures now for variables or lettered variables. 9 equals 6 plus x, 22 equals x minus 10. So now the process that you are going to go through for us is x plus 11 equals 24. What your brain should say is, what is the inverse operation? I have addition, so my inverse operation is subtraction. Now, how are you going to show this? How are we going to organize this? You're going to show how you would find the answer. It's like the story. Okay, I don't want to say once upon a time there was an equation, the end. Okay, we need to go through the story. The story of the inverse is x equals 24 minus 11. I take what my answer, my simplified answer, and I do the inverse operation. That is super important. Then the conclusion of the story is to simplify that. X equals 13. So let's take a look at another story. Once upon a time, 99 equaled x plus 12. My brain says, oh, what is the inverse operation of addition is subtraction. Now I'm giving my supporting details. Show how you would find the value of x. Well, I would take my 99 and subtract 12 to get to the value of x. That's my story. That's how I got to the end. My conclusion is 87 equals x. Okay, now I can say the end. If I use my substitution skills and put 87 in for x, it would say 99 equals 87 plus 12. Is that a true statement? Yes. Okay, if it was not true, then you know that you did something wrong in your subtraction. Here's once upon a time, x minus 11 equals 24. Okay, well now I have a subtraction problem. My brain, in its quickness, would go, okay, what's the opposite of, or what's the inverse of subtraction? And that would be addition. So then my supporting details that I need to show is x equals 24 plus 11. My concluding paragraph is x equals 35. Now I can say the end. I can't skip that x equals 24 plus 11. We want those supporting details in there. 99 equals x minus 12. My brain says I have a subtraction problem. The inverse of subtraction is addition. Show how you would find the value of x. Again, my supporting details. 99 plus 12 equals x. Okay. Then my final paragraph, 111 equals x. I can check my answer. Does 99 equal 111 minus 12? If your answer is yes, then you did the problem correctly. So what you're going to see on your lab sheet is something similar to this. And again, we're about order and organization in algebraic equations, especially when you're going to get to multi-step things that you're going to see next year and the year after. So the way that we're going to organize it is, if you can see in the left-hand box, we have equation y minus 10 equals 57. Okay. Then we are going to show the inverse equation. Y equals 57 plus 10. Could I write 57 plus 10 equals y? Yes. Then you're going to write your solution. Okay, again, your concluding paragraph that y equals 67. If you look at the box on the right-hand side, okay, I'm throwing in some fractions. So again, we're going to have the equation written. 18 equals x plus 12 1/4. My inverse operation is 18 minus 12 1/4 equals x. And then my solution is 5 3/4 equals x. There's going to be a spot for your scratch work. If you need to do the computations, you're going to write them on the right-hand side using any strategy you want. If we're dealing with fractions, remember addition and subtraction with fractions needs a common denominator. So we're going to stop here, and what you're going to do is complete lab sheet 41. Okay? Leave this on your screen as a guide and as a reference tool for how you need to solve the problems.